Flamingos aren't born pink, so what changes them? Everywhere you look, they're impossible to miss. Thousands of birds standing together, glowing in shades of pink that almost seem too bright to be real. It feels as if nature picked one color and gave it to one bird. But here's the strange part. Not a single flamingo begins life that way. A baby flamingo hatches covered in soft gray or white down, no hint of pink, no hidden color waiting to appear. Somehow, over months and years, an ordinary-looking chick transforms into one of the most recognizable birds on Earth. So where does the pink actually come from? Is it something built into their genes, the salty lakes they live in? Or is the answer hiding in something much smaller than the birds themselves? At first glance, the explanation seems obvious. Flamingos eat shrimp. Shrimp are pink, so flamingos become pink too. Mystery solved. Except it isn't. If eating shrimp alone turned animals pink, countless seabirds would be rosy too. Pelicans, gulls, and herons all eat shrimp from time to time, yet none of them look like giant pink feathers on legs. Another idea is that the water somehow stains them. After all, many flamingos live in brilliant red or orange lakes rich in minerals. Maybe the water acts like a giant dye bath. But that doesn't work either. Wash a flamingo and its feathers stay pink. Move one to a different habitat with the same diet and it keeps its color. So if the answer isn't the water and it isn't simply shrimp, what are flamingos collecting from these strange lakes? To understand that, you have to watch how they eat. A flamingo doesn't chase fish or dive underwater. Instead, it lowers its head upside down, sweeps its oddly shaped bill through the water, and pumps with its tongue like a tiny biological machine. Inside the bill are rows of fine comb-like structures that work like a filter, trapping microscopic food while muddy water flows back out. They're not searching for large meals, they're harvesting millions of tiny ones. And hidden among those tiny organisms is the real source of the flamingo's color. The journey begins with sunlight. Tiny algae floating in shallow lakes use sunlight to make food through photosynthesis. Along the way, they produce colorful molecules called carotenoids. These are natural pigments that appear in many plants and microorganisms, creating brilliant yellows, oranges, and reds. You've seen carotenoids before without realizing it. They're responsible for the orange color of carrots, the red of tomatoes, and even the pink flesh of wild salmon. But algae don't keep these pigments to themselves. Tiny crustaceans, including brine shrimp, feed on the algae and store those same carotenoids inside their bodies. In other words, shrimp aren't creating the color, they're borrowing it. Then the flamingos arrive. By filtering enormous amounts of water every day, they consume algae directly, along with countless tiny crustaceans that have already concentrated the pigments. It's like following a trail of color through the food chain. Sunlight feeds the algae make the pigments, the shrimp collect them, and finally the flamingo gathers them all together. But even now, the bird isn't pink yet. Simply swallowing colorful food isn't enough. The pigments still have an incredible journey ahead. Inside the flamingo's digestive system, the carotenoids are absorbed and carried to the liver. Think of the liver as a sophisticated chemical workshop. It modifies some of these pigments and prepares them to travel safely through the bloodstream. Eventually, the carotenoids reach growing feathers, skin, and other tissues where they're carefully deposited. The pigments become part of the feather itself. They're not painted on the surface, they're built into the feather as it grows. That's why flamingos don't suddenly change color after one meal. Every new feather develops while the bird is using pigments from its diet. As older feathers wear out and are replaced during natural molts, the new ones emerge carrying fresh carotenoids.
Little by little, grey gives way to pale pink. Pale pink deepens into rose. In some species, it can even become a rich crimson. It's a slow transformation that may take years, not days. And here's another surprise. What happens if a flamingo suddenly loses access to carotenoid-rich food? The answer is hidden in its next molt. The feathers already on its body stay pink because the pigment is locked inside them. But the new feathers growing in without enough carotenoids are much paler. Over time, the bird gradually loses its vibrant color. Its appearance is constantly being rewritten by its diet. That's why captive flamingos in zoos don't stay naturally pink unless they're given foods rich in carotenoids or specially balanced diets containing those pigments. Without them, their famous color slowly fades as new feathers replace old ones. So a flamingo's color isn't permanent. It's a living record that keeps updating throughout its life. That also explains another mystery. Why are some flamingos barely pink while others look almost red? Part of the answer is simple. Different flamingo species naturally vary in how intensely they process and deposit carotenoids. Age matters too, because young birds haven't had enough time to build up their full coloration. Health also plays a role. A bird that struggles to find food or process nutrients may not deposit as many pigments into new feathers. This leads to an intriguing idea that scientists have been studying for years. In many flamingo populations, brighter birds often appear to be healthier and better nourished. During courtship, that extra splash of color may help signal that an individual has been successful at finding food and maintaining good condition. The relationship isn't identical in every species or every population, but there's strong evidence that vivid coloration can act as an honest advertisement of overall health. In other words, a flamingo's feathers may be saying much more than just "I'm pink." They may be saying, "I've been thriving." But perhaps the most remarkable part of this story isn't about flamingos at all. It's about everything beneath them. The brilliant colors filling an entire flock don't begin with the birds. They begin with microscopic algae drifting in shallow water, powered by sunlight. The chemistry of a wetland influences which algae can grow. The algae determine how many carotenoids enter the food web. Tiny crustaceans pass those pigments along. Flamingos collect them through one of the most specialized feeding systems in the bird world. An entire ecosystem works together to paint a single feather. Scientists are still investigating exactly how different flamingo species regulate carotenoid metabolism and how genetics interacts with changing environments to shape their color. They're also exploring how climate-driven changes to wetlands could affect the availability of these pigments in the future. That means a flamingo's pink feathers don't just tell us about the bird, they can also reveal something about the health of the habitat it depends on. The next time you see a flamingo, it's worth remembering that you're not simply looking at a pink bird. You're looking at sunlight captured by algae, passed through tiny shrimp, transformed inside a remarkable liver, and woven into feathers one molt at a time. Every shade of pink is a story written by chemistry, ecology, and evolution. A reminder that sometimes the most spectacular colors in nature don't come from the animal itself, but from the invisible world that keeps it alive.